We're going to start stoichiometry with an idea about proportional relationships. Let's take a look here at this recipe. This is a recipe for chocolate chip cookies, and these are all the ingredients. It takes 2 eggs to make 5 dozen cookies. If I have 5 eggs, how many cookies can I make? This is an example of where I could use dimensional analysis in my real life if I ever wanted to. If I have 5 eggs and I know that the recipe calls for 2 eggs per 5 dozen, then I can make 12.5 dozen cookies. This right here is the ratio of eggs to cookies. Stoichiometry just looks at ratios in chemical equations. So it's the mass relationships between the substances based on this coefficient that we call a mole ratio. So this equation right here tells me that for every 2 moles of magnesium, it needs to react with 1 mole of oxygen to form 2 moles of magnesium oxide. Looking at this formula, 2K plus S equals K2S. The coefficient ratio between K and S is a 2-to-1 ratio. That means that for every 2 atoms of potassium, you're going to need 1 atom of sulfur to react with it. So 2 moles of potassium react with 1 mole of sulfur. See, remember, atoms and moles are related to each other, and we're going to use the mole to relate atoms to grams. These are technically the stoichiometry steps. You're going to write a balanced equation, identify the known and unknown, line up conversion factors. The conversion factors can include molar volume, molar mass, but will always include the mole ratio. That's the core step in all stoichiometry problems. And then you can go through and check your answer. So as we go through the examples today, make sure you think about these 4 steps. Here's the flow chart to solving stoichiometry problems. Some people really love this chart. Other people, it confuses them. But basically, you're going to read it from left to right. These are your given quantities, which are given to you in the problem. Here's your unknown quantities. This is what you're trying to find. So if you're given moles of one and you need to find moles of another, you just go from moles to moles using the coefficient ratio. If you're given the mass of one of the reactants and you need to find, say, the mass of one of the products, you need to convert that mass into moles, use the coefficient ratio of the moles to moles, and then go back into mass. This is going to make a little bit more sense as we work through these problems, and I'll maybe come back to this flow chart to show you how I'm using it. Here we go with the first stoichiometry problem. How many moles of potassium chlorate must decompose in order to produce 9 moles of oxygen gas? This is a decomposition reaction. This potassium chlorate is going to turn into potassium chloride and oxygen gas. In order to do this, we're going to start with our 9 moles of oxygen gas. Now, this is just moles to moles, so I'm going to use the ratio here. 2 moles of KClO3, you will produce 3 moles of oxygen. So I want to write that on my dimensional analysis. I'm going to make sure that everything cancels, moles of oxygen cancel, and you're left with moles of KClO3. Plug this into your calculator or just do it in your head, and you end up with 6 moles of KClO3. Here's another equation. This is a synthesis reaction. If we have 10 moles of K, or potassium, how many moles of S are needed to use the potassium up? So now we're looking at a ratio between the reactants. 2 atoms of this, remember, are used for every 1 atom of this. So we're going to write it like this. 10 moles of potassium are needed to react with a certain amount of moles of sulfur. Now you might be able to do this one in your head, but I just want to show you how you use the method. So line everything up, putting your coefficient ratio of 2 to 1, 2 to 1 in the problem. Make sure everything cancels and you'll get your answer, which is 5 moles of sulfur is needed to use 10 moles of potassium up. This one might look a little bit tricky, but I want to show you that now if 30 moles of chlorine are used, how many moles of iron 3 chloride are produced? We're going to use this ratio here. For every 3 moles of chlorine, you're going to make 2 moles of iron 3 chloride. 30 moles of chlorine. Here's our coefficient ratio. 3 to 2 ratio. Cancel, and you end with 20 moles of iron 3 chloride are needed to react. Remember, we're multiplying the numbers on the top, dividing the numbers on the bottom. 30 times 2 divided by 3 equals 20. Now make sure you use the right number of sig figs. 1, 2, 3. 1, 2, 3 sig figs. How many moles of water are required to produce 0.5 moles of oxygen? So now they gave me an amount of a product and they want to know how much of the reactant I am going to use. It's all the same thing over and over again. We're going to use the coefficient ratio of 1 mole of oxygen to 2 moles of water. See? 1 mole of oxygen to 2 moles of water. 0.5 times 2 divided by 1. Check and make sure everything cancels. You get an answer of 1.0, proper number of sig figs, moles of water. Now let's move into one more step. Let's go from grams. So in this case, we're going to start with moles. We have 4 moles of copper, but I want to know how many grams of silver I'm going to make. I'm going to start the problem the same way I did before. I'm going to start with 4 moles of copper, and then my next step is going to be that coefficient ratio of 1 mole of copper to 2 moles of silver. You can cancel that out, and now you're in moles of silver. Now, unfortunately, moles of silver is not what we're looking for. We're looking at grams of silver. So now I need to go to the periodic table and find out how many grams of silver will be in 1 mole of silver. So for every 1 mole of silver, it has a molar mass of 107.87 grams of silver. And I find that from the periodic table. Go ahead and make sure that cancels, and now you can see you're left in grams of silver. Multiply everything on the top, divide everything on the bottom, and you're left with 862.96 grams, or 900 grams if you're using the correct number of sig figs, since there was only one significant figure in the problem. The next example, we're going to also have moles reacting, and we're going to find out how many grams are produced. 30 moles of chlorine are going to react. I'm going to find out how many grams, a 3 to 2 ratio. Make sure those moles cancel. Now I want to know how many grams of iron chloride are per 1 mole of iron chloride. I need to go to the periodic table and I need to add up 1 iron plus 3 chlorines. I get an answer of 162.2 grams per 1 mole of iron chloride. Cancel the moles of iron chloride out, and I'm left in grams, giving me an answer of 3,240 grams with that 3 sig figs. So in my calculator, 30 times 2 times 162.2 divided by 3. It doesn't matter what order you plug them in. Now we're going to have grams to grams. So we have an extra step. Remember that chart that I showed you? In order to go from grams to grams, you need to go through the mole. So first I'm going to start with what I was given in the problem, which is 12 grams of copper. But I need to get that into moles. So I go to the periodic table and I can find out that there are 63.55 grams of copper per 1 mole of copper. Now it's time to use that molar ratio. 1 mole of copper is going to form 2 moles of silver. 1 mole of copper for every 2 moles of silver. Cancel out the moles of copper, and now I'm left in moles of silver. I'd be done if it was asking for moles of silver, but it's not. It's asking for the mass of silver in grams. Back to the periodic table to find out how many grams of silver per mole. My units are in grams of silver. 12 times 1 times 2 times 107.87 divided by 63.55 will give you 40.7 grams of silver. Here's another grams to grams, but in this case, we're going to use both reactants. You'll notice the process is still the same. I want to know how many grams of oxygen are going to be required to react with 60 grams of methane or CH4. Start with the 60 grams of methane and find out how many grams per mole of methane from the periodic table. Grams of methane cancel, and it's time for the molar ratio of 1 to 2. 1 mole of methane for every 2 moles of oxygen. We're writing all of this down so that we make sure we're canceling the right units. 2 moles of oxygen isn't going to be good enough. I have to get it back into grams. So to get it back into grams, back to the periodic table to find out that for every 1 mole of oxygen, it's O2, it's 16 plus 16, there are 32 grams of oxygen. That cancels, and we plug it in to our calculator, and we get 239 grams of oxygen. Here's a different one. Now, instead of grams to grams, we're going to go from grams to liters. So from grams through the mole to liters. And it does say you're at STP. If it doesn't say that, you assume it. Start with what the problem gave you, which is liters of oxygen. Convert liters of oxygen into moles of oxygen. You're going to use the conversion 22.4 liters for every 1 mole. This doesn't change. Every gas is the same. There are 22.4 liters per 1 mole of every gas. Now it's time for the molar ratio. It's a 3 to 2 ratio. For every 3 moles of oxygen, there are 2 moles of potassium chlorate. Cancel out that moles of oxygen. Now we want to convert moles of potassium chlorate into grams. So 2 moles, the moles are going to cancel. I got this number from the periodic table, adding 1 potassium, 1 chlorine, and 3 oxygens. Plug it into my calculator. 9 divided by 22.4 times 2 divided by 3 times 122.55. Multiplying everything on the top, dividing everything on the bottom. I get an answer of 32.8 grams of potassium chlorate. This is the opposite. Now we want to know how many liters are going to be made when we start with grams. So we start with 48 grams of oxygen. We're going to convert grams to mole by using my periodic table. I look at the molar ratio between the oxygen and, in this case, the carbon dioxide. They are a 1 to 3 ratio. So for every 3 moles of oxygen, it's going to make 1 mole of carbon dioxide, making sure moles cancel and I don't have these backwards. And now I've got to convert moles into liters at this point. So we know for every 1 mole, it's 22.4 liters. I don't need to use the periodic table for that. Moles cancels, I'm left in liters. In my calculator, 48 divided by 32 divided by 3 times 22.4 liters. I ignore the ones. There's no point in putting them in the calculator. I end up with 11.2 liters of carbon dioxide.